Now we are going to discuss about flood frequency analysis. Here in flood frequency analysis or flood frequency method, the observed data of the past floods is used for the prediction of future floods at a particular probability or return period. And also the earlier floods, the past floods should be taken, that should be more than 25 years, because less than 20 to 25 years the data is also used for the estimation of peak flood by using the recurrence interval analysis, but that will not give reliable values. Here the flood, that means the flood, earlier past floods have taken in two methods. The recurrence interval is completely depends upon the earlier floods data. The data will be taken in two methods. One is annual flood series, another one is the partly duration series. In case of annual flood series, only the highest flood of each year is taken for the analysis. That means, for example, we are going to take 20 years flood peaks. For the 20 years past floods, we are going to take only one peak per year, not going to take 2 or 3 peaks in a one particular year. Whereas in case of partly duration series, we are going to take all flood peaks above the selected peak. Because here this have to give more advantage as compared with the annual flood series. Because a partly duration series has an advantage over the annual flood series, because all the floods above the particular peak are considered. Whereas in annual flood series, some large floods, which may be even larger than the largest flood in the other years, are not considered. That means if the 2015, 2014, 2013, so we have taken some data from 2013, 14, 15. The 2013 peak flood equal to 100 metric cube per second, 2014 150 metric cube per second, 2016 200 metric cube per second. But even 2015 150 metric cube per second is the maximum, 2016 200 metric cube per second is the maximum. In the year 2016 180 metric cube per second, 170 metric cube per second have two peaks in the 2016, but we are going to take only the peak flood, that is 200 metric cube per second. But even the 2015 we are having only 150 metric cube per second, but that is less than as compared with the 2016 data, that is 170 metric cube per second as well as 160 metric cube per second. So here we are going to take only the highest flood in the 1 year, that is the drawback. Whereas in case of partly duration series, selection of level, that means flood level peak selection, that is also one of the, in case of partly duration series. Here the frequency analysis have done different methods. One is a probability plotting method, Gumbel's method, and log Pearson type 3 distribution method. And first one is the probability plotting method. So here in case of probability plotting method itself represents graph, that is a plotting method. The probability plotting method, here we have taken discharge ordinates in the vertical axis and recurrence interval in the horizontal axis. That is also drawn on the log paper. They have given directly the peak discharges of earlier or past 20 to 30 years data. So that is we have directly with respect to, but they have not given recurrence interval. So based on the floods given, we are going to determine the recurrence interval by using one formula, that is here we are using generally 3 formulas for the determination of recurrence interval. One is California formula, that is TR is equal to N by M, and Hazan's formula and Welber's formula. This is the formula generally we have used for the calculations of recurrence interval. TR is equal to N plus 1 by M. Right? Once we know the recurrence interval and also they have given the flood peaks, then we are going to draw the graph on log graph, then we have the peak discharge on a particular catchment area. Right, before going to determine this recurrence interval, the data, given data should be arranged in such a way that first of all we are going to give the year wise first column, second column is the discharges. The discharge should be high discharge, high peak should be put at the top. Then gradually discharge values decreases up to the n number of years data available. Right here, top discharge equal to 3 into 10 power 5 meter cube per second, next one 2, next one 1 point something like that. Corresponding year also substituted in the same location. Right, this is the way. Then we are going to determine the recurrence interval. Here n equal to number of years data available. M is the rank, that means top discharge, peak discharge rank 1, next discharge rank 2, next discharge rank 3, up to number, last number. For example, 20 years data we have, that rank is equal to 20. Here 20 is the last reading, rank 20. Here n variable parameter is the rank. And next one, Gumbel's method. This is also one method for the determination of peak flood on a particular drainage basin. Gumbel's considered annual flood series. So already we discussed about two types of flood series. One is annual flood series, another one is the partly duration series. Gumbel taken annual flood series for the analysis. According to Gumbel, the probability of occurrence of an event x equal to or greater than the value of x0. Here they have given some steps for the determination of peak discharge by using Gumbel's technique. Here they have given floods with respect to year. 20 years floods they have given, or 30 years floods they have given, or 50 years floods they have given based on the availability. And also they have given recurrence interval. Based on the floods, first of all, we are going to determine the mean of the peak discharge. We have different peaks year wise. First of all, we are going to determine the mean, then go to determine the standard deviation. Standard deviation, already I told you one formula that we have discussed in the rainfall analysis. Their standard deviation is equal to square root of sigma rainfall intensity P minus P bar, that is in mean of the P square divided by n minus 1. Same formula here we are also going to use. Q is the peak discharge, this is the mean of the discharges. This is the formula for the determination of standard deviation. Yes, once we know the mean of the peak discharges and standard deviation, and then we are going to estimate the reduced mean and reduced standard deviation. And reduced standard deviation that are calculated by using the recurrence interval or return period. Based on the return period, these values are variable. This is the table for the determination of reduced mean or reduced standard deviation. Here 10 years return period, 10, 15, 20, 25, 30, 40. Here they have given 25 years return period. The corresponding reduced mean is 0.5309 and corresponding reduced standard deviation is equal to 1.0915. If they want to 30 years return period, these are the values. They want to 40 years return period, these are the values. Once we know the reduced mean and reduced standard deviation, then we are going to calculate the parameters, these A and QF parameters that are the depends upon the catchment characteristics. Here A equal to reduced standard deviation divided by standard deviation, and QF is the Q mean, already we determined earlier. So reduced mean divided by reduced standard deviation into standard deviation. Then we are going to determine the variate YT. This is the formula given directly. Return period they have given, and YT variate YT is equal to minus log base log E TR by TR minus 1. This is the formula here. TR is given only for the using this formula we are going to determine the variate yt, then finally we are going to determine the peak discharge. So qt equal to qf already we determined earlier, yt is the variate here, this is the value for the determination of yt, and a is also determined. So finally we are going to determine the peak discharge on a particular catchment area. So this is one formula. The maximum annual observed floods for 20 years from 1950 to 1969 for a catchment area given below. Determine the maximum flood with recurrence interval of 30 years. The following method, one is probability plotting method and another one is the Gumbel's method. Here they have given 20 years data, 1950 to 1969. This is the 1950 peak discharge 1.38 lakhs, means into 10 power 5. 1951, this is the peak discharge, like that these are the discharges corresponding to year. Here 1967, the peak discharge equal to 1.50 into 10 power 5. This is the discharge. They have given discharges, that is the peaks of the year, corresponding year, and the return period also here given recurrence interval 30 years. So how we are going to determine the peak discharge by using the for the determination of peak discharge by using probability plotting method. This data will be arranged in such a way that this is the year wise discharges. Here this is the year. The discharge should be arranged like this. The peak discharge is put at the top. The corresponding discharge, this is less discharge, gradually the decreasing order here. The peak discharge here, the rank is given 1. And next discharge is equal to 1963, 1.95, rank equal to second rank. And third rank 1.92, this is the peak discharge, like that. Lowest discharge, that is the lowest peak, is equal to 1.2 into 10 power 5, that is left outside because for the calculation purpose, here is taken as only 1.2, that into 10 power 5 is added at the end of the problem. This is the values of discharges in the decreasing order. These are the ranks. Then we are going to determine the recurrence interval. So here, for the determination of recurrence interval, we know one formula, that is equal to TR is equal to n plus 1 by m. N equal to number of years data available here, 20 years, plus 1 divided by m means rank 1. This is the value, and n 20 plus 1 divided by m means rank 2. This is the value, like that we are calculated with. These are the values of recurrence interval. Here what it represents, the recurrence interval equal to 21 years. That means 2 into 10 power 5 meter cube per second discharge is possible only one time at a span of 21 years. In case of 1.95 floods are possible one time at 10.5 years. So here 7 years, only one time we are having 1.92. Like that, here 1.2 into 10 power 5 meter cube per second discharge. This is the lowest discharge is possible. Every 1 year, approximately 1.05. Every 1 year, we are having this much of flood. But this much of flood is possible once in a 21 years. That is the meaning of recurrence interval. Yes, once we know the recurrence interval, we know the discharge. You go to take a log graph, then that horizontal axis here, recurrence interval, vertical axis discharge, then they given the discharge rate. And another method, Gumbel's method. Here, in case of Gumbel's method, first of all, we are going to determine the mean of the peaks. After calculating the mean of the peak, that means Q bar, then we are calculating Q minus Q bar. This is the Q value. This is the Q value. Q bar is equal to sum of the discharges divided by number of discharges. Right? So this is Q minus Q bar here, Q minus Q bar square here. Because these two values are used where we are going to determine the standard deviation. Right here, this is the problem. So standard deviation is equal to sigma Q minus Q bar square divided by n minus 1. Here already we calculated here Q minus Q bar. These are the values of Q minus Q bar. n equal to number of years, 20 years data available, then this is the value of sigma. Once we know the means value and standard deviation based on the given recurrence interval, given written period equal to 20 years data available here, based on that we are going to estimate the reduced mean and reduced standard deviation table. Here they have given recurrence interval. Based on the recurrence interval, this is the return period. These are the values of this one. What is the here return period? They asked 30 years. For 30 years, these are the values of standard deviation, reduced standard deviation, and reduced mean values. Once we know the reduced standard deviation and reduced mean, then go to calculate the A value, that is the parameter constant, that is a standard deviation, reduced standard deviation by standard deviation, we have this value. Then go to QF, this is also having one formula, already reduced standard reduced mean already determined by using the table, standard reduced standard deviation also determined by using the table here, and Q bar is the mean already determined. Finally you have that QF value, this one yt is equal to, apply this formula, determine the value of yt is equal to this one. Finally the peak discharge equal to 2.2929. This is and that multiplied into 10 power 5, that is put outside, then that will be added here 2.2927 into 10 power 5 Qmax. This is the peak discharge on a particular catchment area by using the Gumbel's method. And one more method, that is the log Pearson type 3 distribution method. This is also one method apart from the probability plotting method and Gumbel's method. Here what they done, first of all, transfer the given variate into logarithmic form. Suppose they have a given Q is the variate, that is the discharge, peak discharges, that may be converted into logarithmic form, that is y equal to log Q base 10. Then once you convert this value y is equal to log Q base 10, then you are going to determine the variate yt based on the given time period, that means probability or recurrence interval tr. So here variate yt equal to y1 plus k is symbol sigma, this is q. Here k value is determined based on the given recurrence interval and q value g. Once we know the g value and recurrence interval they have given in the problem, then we are going to k value by using the table. Here y1 is the mean of the, this is the value, this is the formula for the determination of q value, n sigma y minus y bar divided by n minus 1 into n minus 2 into standard deviation cube, sigma cube. Here y1 is the mean of that logarithmic form and n equal to number of samples given, sigma equal to standard deviation. The value of qt can be obtained as anti-log of this one. Right here, this is the table for the determination of k value, that is the frequency factor. This frequency factor is depends upon this q value. Already we determined q value here by using this formula, and also return period they have given. So based on the return period here, 2 years, 5, 10, 25, 50, 100, 200,000. Suppose they have given 25 years return period, corresponding q value is equal to in between these two, 1.5 and 2.5, that value is equal to 1.75. We are going to take the return period is equal to 25, which these two values go to interpolate and you have the value of k. If they have given, here we have only 10, 25, 50, 100, 200,000 like that. If they have given return period is equal to 30 years, so we are going to take in between these two. For example, q value in between 1.0 to 1.5, that is 1.25, then we are going to take these four values. Then finally we have the value of k. Once that value, you calculate the k value, that is substituted here, you know the standard deviation by using the formula, and also mean you know. Finally you are going to determine the yt. Once you know the yt value, finally determine the peak discharge on a particular catchment area. This is one problem. So this is the steps what we have discussed earlier. First of all, the given annual flood discharge is converted into logarithmic form, y is equal to log q base 10, then determine the mean of the logarithmic form y, then determine the standard deviation and also determine the skew value G. Then go to given return period, based on the return period and give a calculated Q value, then you are going to determine the frequency factor K. Once you know the frequency factor K, you are going to determine the YT, variate YT. Once you know the YT value, you are going to determine the peak discharge. This is the one problem by calculation of peak discharge by using the log Pearson or type 3 distribution method. Here from the annual flood series, here also they have taken annual flood series table, determine the maximum flood with a recurrence interval of 30 years. Here they have asked 30 years recurrence interval log Pearson type 3 by using the log Pearson type 3 distribution method. Here they have given years. These are the discharges. Here for the determination of peak discharge by using the log Pearson distribution method, we should know the logarithmic form of the given discharge and also determine the standard deviation, mean value and also frequency factor K. For determination of frequency factor K, we should know the recurrence interval. They have given 30 years and also Q value. For the determination of Q value, we should know the this values y minus y bar square and y minus y bar cube. Here as like as earlier problem what we have done earlier for the by using Gumbel's method. So this is the year. Then you are going to arrange it like this, the discharges, and go to determine the logarithmic form of discharge. This is the given discharge Q that may be converted into like this. This is the value 0.301, 0.29. These are converted into by logarithmic form. These are the values. So once we know the y value, then we are going to determine the mean of this value, that is y bar or y1. So then y minus y bar square, y minus y bar cube. These three values are used where we are going to determine the skew value. Here standard deviation, this is the mean y bar equal to, we know the sum of the given discharges divided by number of years data 20. This is the value y bar, that is mean of that logarithmic form is 0.2072, the standard deviation. This is the value. Then we are going to determine the skew value by using this formula. Y minus y bar cube already determined in the earlier table. This is the values of y minus y bar cube. Then we have the skew value. Once you know the skew value and also they have given 30 years return period, by using these two values we are going to determine the frequency factor K by using this table. By using this table here they have asked for 30 years return period, not 25 years and also not 50 years, in between 30 years. Then the value is minus 0.35. That means in between these two, this is the value. We are going to take these four values and then calculate by using these four headings. Once we know the K value, then calculate the variate YT y bar, that is already we calculated mean, and K is the taken from the table, and sigma is also determined. Standard deviation YT is equal to this one. Finally peak discharge, that is design flood, is equal to 2.098. Then again here we are going to add that into 10 power 5. That is put outside at the starting of the problem. Here 2.098 and into 10 power 5, this is the 2max. So here observed that by using the Gumbel's method, the peak, the design discharge is equal to 2.2 something, here 2.098 into 10 power 5. Almost all two methods have almost all equal values. This is the procedure calculation of design flood by using the Gumbel's method, probability plotting method and log Pearson type 3 distribution method.